Hi everyone. Good morning, Sir Bao. Good morning, teachers. Today we will be talking about Poisson probability distribution. For today's objectives, first, define Poisson probability distribution. Second, provide an example of Poisson probability distribution. Third, instill understanding and importance of the concept Poisson probability distribution. All right, just a quick trace of history. Baron Simeon Denis Poisson, born and lived in France from 1781 to 1840. The French mathematician who developed his function in 1830 and who first introduced the Poisson probability. He was also a physicist who worked on statistics, complex analysis, partial differential equations, the calculus of variations, analytical mechanics, electricity and magnetism, thermodynamics, elasticity, and fluid dynamics. He also won an award, Copley Medal. Now, before we discuss our lesson, let's know first how to pronounce this word. In France, they called it Poisson. Poisson. But in English, we generally called it Poisson. All right? Now, let's define Poisson or Poisson distribution. In statistics, a Poisson distribution is a probability distribution that is used to show how many times an event is likely to occur over a specified or specific period. Now, what is this probability distribution used for? This is used for to describe the distribution of rare events in a large population. Say, for example, at any particular time, there is a certain probability that a particular cell within a large population of cells will occur or acquire a mutation. Mutation acquisition is a rare event there. All right, another example for real life experiences. What is the real life example of Poisson distribution? First, the number of Airbus 330 aircraft engine shutdowns per 100,000 flight hours. Another, the number of asthma patient arrivals in a given hour at a walk-in clinic. Another example, the number of hungry persons entering McDonald's restaurant per day. And our last example, the number of work-related accidents over a given production of time. So you see, Poisson distribution there is to describe the distribution of an event in a large population. Why is it called Poisson distribution? Now, it is called Poisson distribution because it is named after French mathematician Baron Simeon Denis Poisson. And this Poisson distribution can also be used for the number of events in other specified interval types such as the distance, area, and volume. Now, why is Poisson distribution important? So Poisson distribution is important because we need it to do interesting things in life, like finding the probability of a number of events in a time period or finding the probability of waiting some time until the next time event. Poisson distribution is actually a tool because this will help us in predicting the probability of certain events. So you see the probability there is from 0 to zero point 0.6. You can see that the probability is helping us in predicting such certain events. And then when you know that it's happening, you know also how often the event has occurred. And it also gives us the probability of a given number of events happening in a fixed interval of time. Question: how do you know if a distribution is Poisson? Right? You will know if the distribution is Poisson if a variable follows and when the following conditions are also true. First, we have the data or counts of events. Second, all events are independent. Third, the average rate of occurrence does not change during the period of interest. So you see, if a Poisson process meets the following criteria, in reality, many phenomena modeled as Poisson processes don't meet those exactly the events. And if the events are independent of each other, the occurrence of one event does not affect the probability another event will occur. In other words, the average rate or events per time period must be constant. All right, let's check if we achieved all the objectives for today's lesson. First, define Poisson probability distribution. We defined already the Poisson probability. Second, I provided an example kanina with the life experiences about the Poisson probability. And lastly, we have an idea now of the importance, and of course, we understood the concept of Poisson probability distribution. To end this discussion, I would like to leave you this quote coming from Pierre Simon Laplace. He said that probability theory is nothing but common sense reduced to calculation. Again, thank you for watching and listening. I hope you learned a lot for today's lesson. So I guess that's it. I'm Grace Miranda signing off. Thank you.